Hey math students, got a little puzzle here for you. This is the introduction of solving systems. And just as a quick reminder, how did you solve linear systems? You did it by elimination, graphing, and we're going to do substitution and replace. But here's my little puzzle. Can you draw the pictures that kind of show, for example, in this column in blue there, it's linear and a linear. Can you draw me two linear graphs that have no solutions or no intersections? Over here, can you show me a linear and a quadratic that have, in this middle column here, one solution or one, and then the quadratic, can you show me that it has infinite amount of solutions or intersections? Press pause, and then I'll give you a hint. All right, here's hint number one. A linear and linear has zero solutions. So here's my graph. Zoom in over here. This is a linear. Question. Do the two lines intersect? No. So there is no solution there. Let's try a linear and quadratic that has one solution. We could draw a quadratic here. Let's say that goes this way. So then our intersection, the one solution would be that red dot. And let's go ahead and try a quadratic and a quadratic. Did orange, let's try orange. And we're trying to get infinite amount of solutions. So here's my one graph. Here's the second one. It's going to go fast. Whoa, why is that the case, right? Because the point of intersections are every single point. I can draw dots all day long about the number of solutions, right? Looks like it's sick. So, all right, you finish that up. Press pause, and then I'll show you guys the rest of those solutions. All right, so the graphical one solution for linear is just going to be a intersecting, right? All right, you guys want to hear my story? Okay, you got to hear my story. This is like world famous. This is like the most famous story sometimes my students love, okay? There's two lines there, and the two lines come into class, and I make them sit next to each other, and they look at each other and say, hey, do you want to hang out and go on a date? Or, and they're like, nah, we're never going to go on a date. That's no solutions. Their love lives are parallel. I set them next to another two students together, the blue and the green, and they look at each other like, whoa. Looking at each other, and then they decide to go on one little hangout, one little date. Come back to class the next day, I'm like, let's do it again. Oh, no, sorry. And then the last one, you guys are going to like this one. Set them next to each other, and whoa, they're on top of each other. Why? They're like one, right? Their love lives are infinite. Their commonalities are infinite. Do you like that? It's better. I use pencils and stuff like that. But let's do a linear and quadratic. Let's do something different, right? Whoa. Totally miss it, right? No intersection, no dates, no solutions about it. Okay, how do you get an infinite? Okay, this one's going to be impossible, but so there is no infinite. But there is one I missed. There's actually two solutions. Can you think of it? Yeah, you just have a, and somehow it goes this way, right? Then your two solutions are going to be there and there, okay? And let's do the quadratic and quadratic. Can we have it where it has no solutions? Can you think of something? How about this? Right? Okay, how about a graph that has quadratic that has one solution? Okay, this one's going to be a tough one. Let's see if we get it. There's one. How do you get the second one? Whoa. Take a look right there. Bam. One solution. And then there's the infinite solutions. Okay, so that's introduction of solving of systems of equations, linear, 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 quadratic, 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 and then we're going to be focusing on the substitution method. All right, see you guys.